Episode 12. Week 12. What was that? What was that song that was on Sesame Street? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You remember that? It was like a ball going through a pinball machine.
Yeah. I think we should really just do what was it? One count. The vampire that counts a lot. To the 12 one. Oh, we'll do it. Episode 30.
Episode 30 is just us counting to 30 over the course of an hour.
That's my favorite comedy group at the moment. Arnie Donna did that for their 300 episode. They just read out their episode names in the voice of an actor from the movie 300. A guy called David Wenham. They just pretended to be David Wenham and read out 300 episode titles. So 300, we'll do that as well.
Okay. And, you know, hopefully we're famous enough by then that Auntie Donna can join us and we can all do it together. I don't think that'll happen, but you never know.
Well, not with that attitude.
That's true. That's true. I mean, they probably know a lot about AI models and stuff.
Good morning.
Mate, how you doing? Yeah.
Good.
We're doing a little bit earlier because you've got some fun plans for the weekend.
Yeah. Off to Scotland with my little sister and the dog, so that'll be great.
Very nice.
Are you off to Scotland with the dog this weekend?
No, I don't know what I've got planned this weekend. Probably just kick around at home, edit a few videos.
Not yours.
Don't know. Just random videos.
Recut Avatar.
I just Yeah. It's not the director's cut, it's Elliot's cut. I don't have any additional footage. I just reorder major plot points. Yeah, you know, take that, what's that, business bottom line up front sort of mentality. I just take the last 30 seconds and play it at the start and then fade in. And so if you don't want to watch the rest of the movie, you know the ending right at the beginning. It's all about hyper productivity, man.
Top-down communication movies.
Yeah, absolutely, man. Like, that's, you know, we've been talking about the book 4,000 Hours. You got a limited amount of time, so I just put the end of all the movies at the front, and that's the Elliot cut.
Yeah.
So
Avatar.
look out for that.
Human industrial complex is bad.
Yeah, basically.
How do we come back from this? Come on, segue us. I believe in you.
I don't know, man. Let's just pause for like 8 years like Avatar did, and then we'll finish this thought.
What am I making
you drinking?
Well, I'm making you drink at 3 p.m. What are you drinking?
That's true. It's not 3, it's 4. So it's 5 o'clock in a lot of places. I have got the Zombie Pop Part 2 Boysenberry and Blueberry Imperial Sour by Hop Nation Brewing Co. It's not bad. Like, I don't know if I get it again, but it's not bad. I got Part 1 as well, but I thought, you know, the Part 1's guava. I went for the boysenberry, but yeah, it's all right. What are you drinking?
Is there going to be a Part 3?
I have no idea. Maybe it's like Avatar. We'll wait and see.
I'm going to pretend to sponsor this show as a beer company, so you stop drinking these gross beers. I'm just going to pretend to be
They're
from...
gross.
They're gross.
I'm gonna pretend to be from a florist so that we don't have to slowly watch your flowers die in the background of your photo every week.
They're wilting. They're actually quite alive. Leave them alone. I am drinking the Zeroka blend today, Cafe Thierry method. So, and it's piping hot. I can't drink it yet.
Oh, well. Good. All right, so we've got 2 topics for this week, as per usual. Both of them have a little bit of the Google flavor this week. So I think, Tom, you are up first this week.
Yeah,
I'm
up first.
Take us away, man.
So this week, I want to talk about a article I came across in The Economist called "Alphabet is spending billions to become a force in healthcare." And the point of the article is that tech companies are spending a lot of money investing in healthcare to become big players in it. But Alphabet is spending the most out of all of these by a significant amount. So if we take a look at a few of the stats, and what I wanted to discuss today is actually 2 things. The first one is are these companies actually spending a lot? And the second one is, are they going to have some winners? Is their model, is their venture capital model that they're taking going to produce some winners? And then bonus content, if we don't run out of time or things to talk about, is just running through Google's health portfolio. So,
top 300 Google Health portfolio.
Deep mind. I know I'm going to listen back on that and hear myself do a voice and cringe. But anyway. So, tech is investing a lot in healthcare. So if we look at the numbers, in 2021, they invested 3.1 billion. And these are mainly venture-backed businesses or venture-style businesses. In fact, it's a relatively large proportion of all of healthcare investment in startups in 2021. It was 60 billion invested in healthcare startups in 2021. But if you think about the acquisition model that these players do, they're not venture capital funds. So they're doing, and they usually just buy the whole thing rather than back in a portion. So they're actually doing it's quite a lot of the bigger deals. And you can understand why. So the question of why is tech investing in healthcare? And I think it probably comes down to the main point that healthcare is such a big market. It's ridiculously big. It's like 17% of GDP in the US, which is...
That is a lot.
Yeah, it's like nearly $4 trillion. Everyone's like, "Ooh, defense is a big industry." It's like 5 times defense. And the other thing about health is that it's growing. Usually when these industries get so big, they kind of plateau. If you consider the energy industry, and by the energy, I mean like the electricity market, it's sitting at 2 to 3% growth a year, sometimes negative growth. In fact, electricity consumption is going backwards and all the growth has been in prices. So it's growing, and any market that's big and growing generally attracts big players. And the reason is that it's easier to grow within a business, within an already growing market, rather than a big market that's growing, rather than create an entire new market from scratch. Even though, ironically, all of these companies came from a place of zero.
Yeah, I guess once you get to a certain size, your risk appetite sort of decreases a bit. You got to protect the kingdom rather than, risk it for a new kingdom.
Yeah, exactly. And so Alphabet is the biggest spender out of the FANGs, which is the Facebook, Alphabet, Amazon, Netflix, Google. I've always found it a bit weird that Netflix is in there, but and Microsoft.
Dude,
as well.
Netflix employs a lot of people.
Yeah, but from a revenue and market cap point of view, they're like a fifth of these companies, right?
Yeah.
I think they just wanted the acronym.
Yeah. Well, I mean, it's even weirder now because it's not Facebook anymore, is it? It's Meta, so it's like Mang.
And also, I missed
which
Apple.
Is not as cool.
Did I miss Apple?
Well, what's the A otherwise?
Well, there's 3 A's. Amazon. Oh no, G's Google.
Yeah,
Anyway.
even though that should be I don't
They're
know.
spending the most out of Amazon,
tech-
Apple, Facebook, and
big
Microsoft
on health.
on health. So they've already spent about $2 billion this year in 2022. I think from the graph I could figure out that they probably spent like 2.5 of the 3.1 billion in 2021. So they're investing a lot. In fact, they're the biggest paper producer and researcher in the life science industry outside of a pharma company. So the top four, I'll say, paper producers are pharma companies. And then it's Alphabet at number 5. Then it's about another 14 pharma companies, followed by Microsoft at number 20. So they're outstripping all of these people in investment in health, which is super cool and super interesting. And they're starting to do some really, and they've got some really cool stuff. So obviously DeepMind is probably one of their flagship products in the healthcare space. They've also now kicked off their Care Studio, their electronic health record again it's called Google Care Studio. and what they're doing there. We should probably do an entire episode on like how they're building these and how they're building them for searchability. If they get these right, they're going to be amazing. But
yeah, man, for sure. And they have Verily as well. I don't know if that was mentioned.
Yeah.
It was like that big consumer-facing thing that's now flipped, I think, back into more of that patient management system space.
Yeah, so the Verily seems to be all about basically kind of B2B solutions, helping precision, like their goal is to bring precision health to everyone.
Very cool.
So lots of cool stuff happening, lots of cool stuff. And the first the two things I wanted to talk about though is, are they investing enough? So 3.1 billion. Sounds like a lot, right? A lot of money. But let's just take a few.
Yeah, at an absolute level for sure.
let's take a few comparisons here, okay? In terms of revenue, Google, let's call it $2 billion. Google earns over 230 billion a year in revenue. So pretty small.
It's like 1.5% ish.
If you compare that to a few different investors in the healthcare space, Pharma invests about 20% of revenue each year into R&D. The top 5 pharma companies invested 50 billion in 2020, and apparently that was 2021, and that was a slower year. So we're kind of talking the 2% compared to 20%. Now it's tech, and they're not a pure healthcare play, so it's not apples for apples, but it's an order of magnitude different.
Yep, not Netflix's for Netflix's. Yeah, because I was going to say, like, if you think about what Google is investing in or Alphabet is investing in, it's often tech platforms. And, like, if you look at all the money they spent on, say, Google Cloud, like, how do you portion that against R&D and things like that? But, like, I get your point.
Yeah.
It's, it definitely seems like a line item rather than a direct business focus.
And I'll make a circuitous path to my point as well at the end. The kind of where I'm at is, are they spending enough to get a success? I think they're doing some really cool stuff, but my overall question here is that I feel like we've been hearing a lot about these companies wanting to be healthcare plays for a long, long time, and they haven't had a huge win yet. None of them have had a huge win.
What do you think, though? Like, what do you think success looks like for Google?
Searchable electronic health records. That's success for them.
So, like, taking on the Cerners or the Epics of the world.
Cerner's now Oracle, which they got bought last week by Oracle, which is big news in the space. So it's taking on those. And what could be super interesting here, and I might be lambasting Google and for nothing here, is that we could be sitting on the foundations of searchable patient health records, which would just mean a huge and interrogatable patient health records.
Yeah, and like indexed. And so I mean, we've talked about this so many times, but just like having that, Tom and I work in healthcare. We get faxes, we get data that's unstructured, we get all sorts of stuff. If somebody can solve that and put data in a way that's structured and then queryable and then feedable into machine learning, there's just a massive opportunity there to really just raise the bar.
And what I don't really believe that, we're going to get these records and then suddenly cancer's going to be cured. But I think what it could do is really, really make a step change in our ability to do research. And I think it could do a really, really big step change in administration. 25% of the spend of this 17% of GDP spend in the US is on administration, full stop. Not delivering care, administration. Yeah,
I remember a graph, and if I can find it, of jokes on me when I can't find it, of growth in the healthcare industry over the last however long it was, and it was looking at growth in the number of clinical staff versus administrative staff, and clinical staff is like, it's maybe doubled in that time period, whereas administrative staff I think was like 50 to 100 times what it was over the same period, which is just crazy, like there's a lot of admin, a lot of bureaucracy, and we experience it every day. Just to have this stuff running.
No, it blew my mind. That's at 25%.
Yeah, crazy.
So that's kind of the first thing, is that are they investing enough? Obviously not Apple for Apple, but the question with pharma companies, but a question mark still does remain for me as what's the strategy for the Alphabets and the Amazons? Are they wanting to make healthcare one of the biggest parts of their company? Or is it something more interesting, like I once heard that Amazon bought Whole Foods as a customer and as a strategic buy, so they could make them one of their main customers for AWS, and they could use them as a case study for improving inventory efficiency in retailers.
Yeah, I mean, that's a pretty interesting play, especially given Google is currently, I think, sitting behind AWS, and I'm not sure where it sits relative to Azure in terms of cloud usage. But yeah, I mean, if you could get the American healthcare system using Google Cloud as its infrastructure, you could almost deliver the incremental software benefit on top at cost.
Yep.
Just to beat Amazon at AWS.
And I think, as we've learned as well, that healthcare is this weird and wonderful place where decisions have a lot more impact, and privacy and security is a much stronger requirement. And I think if Alphabet can establish itself as the healthcare provider, as the healthcare tech company, they're going to be in such a fantastic spot from a reputational point of view to win contracts like this. Not everyone can win a contract to be the electronic health record provider for the United States.
Yeah, definitely. And I mean, two things come to mind there. One, privacy in general, and do you want Google to have all your health data, which we can talk about, and it's probably a job for the whoever it is in the US that manages these mergers and disallows sort of anti-competitive behavior. But on the other hand, I totally spaced on what I was going to say.
No, it's exact.
Oh, that's what I was. Yeah. No, sorry.
We'll cut it.
One thing that Amazon and Google do right now is that, like, if you're a small player and you have a solution that you can provide, you can sell it through Amazon and Google, and they'll spin up the infrastructure underneath, and then you can just tack that on to whatever offerings you're getting there. So I think even if Google or Amazon has a big foothold in this market, I mean, it screws the other one, but it doesn't necessarily screw somebody who's building a tool to help, diagnose prostate cancer, for example, because you can now potentially even sell that more easily to existing Google customers. Yeah. Whereas selling through Cerner and Epic has historically been not an easy thing to do. It's possible, but it's quite hard.
You got to keep that Silicon Valley Ponzi scheme going, right?
Yeah, that's it. Yeah.
So that was kind of question one, is are they investing enough? And we haven't by any means answered this question, but I'm very excited to see, because I actually think as well that Google will start ramping up if they start getting some serious wins, which is my next one. The next question is this VC model going to pay off for one of them? So Amazon's had a few wins with pharmacy and telehealth services, but they were just very strategic acquisitions. It was online it was making a play into the pharmaceutical space and delivery of the pharmaceuticals. Wearables seem to be doing really well for Google. Once again, a big acquisition with Fitbit. They're getting some serious FDA wins in there as well. Especially there was Fitbit has now been approved for the oh gosh, gonna get this wrong. It's like the early detection of heart murmurs or something like that. So the FDA, they've now been approved in the FDA for that, which is huge.
Yeah.
But there hasn't been anything groundbreaking yet. So they're back in the healthcare record space. This is the 5th time they're doing the healthcare record venture. Sorry, 4th time. They started in 2008, shut it down, and that's where they first entered Google. They first entered health, and there was the headlines of Google having your data. But they've shut it down 3 times now, and they're back for a 4th. Now, what's different between now and 2008 is that now 92% of hospitals are EHR integrated, but now we're dealing with compatibility, now we're dealing with searchability, and now we're dealing with like back compatibility of data between all of them. So it's not exactly a solved problem.
Yeah.
And as well, DeepMind has only just become profitable, and it's mainly been profitable from selling back to Alphabet, and it's kind of just turning into a consulting service. From a business point of view,
I mean,
I think that
IBM Watson went a similar way.
Yeah, exactly. Like their research is really cool. They're pushing the space, and this is what I like about Alphabet is they make bets that might not necessarily seem like a profitable business decision to begin with, but suddenly they'll end up with something like Google Maps or Google Docs, and it moves the world forward. But where it stands at the moment, DeepMind is only just profitable, and it's from consulting services back to other Alphabet services.
Which is a weird definition of profitable.
Yeah.
It's like your dad giving you pocket money and being like, look, I turned a profit this week.
It's also
because I cleaned the dishes and got money from dad.
It's also called a tax write-off.
Yes, that is worth 50 episodes on its own of, what do they call it? Double Dutch sandwich or something?
They've been making many, many bets since 2008. Well, they started ramping up since 2008, making many, many bets, making 40, 50. And are we going to see some VC? Are we going to see something pay off soon for the likes of Google or one of the tech companies?
Yeah, I mean, given all of their share prices this year, I'm sure they're hoping so. But I guess, it'll be interesting to watch over the next 6 months. You know, are they committed this time? You said they've done it like 5 odd times in the AHR space. They're all kind of getting tanked. Are they going to let go, or are they going to hang on to it this time? I think that'll be an interesting tell of their commitment and their seriousness in this space.
And so I think, their kind of like flagship push is in the EHR, because obviously that's just huge. You can see why Google's interested in it, because it's all around searchability, and also the AI capability and the AI application of it. But the other interesting news, obviously, this week, we've already mentioned, is Cerner being bought by Oracle. Oracle wants to be the EHR provider. It wants Searchable. It wants everywhere across the US. So it's not just Alphabet that's pushing again into this space. So maybe this time's different. Maybe it is. And interestingly as well now is we're no longer all the systems. There's been in 2004, George Bush started pushing for the EHRs to be put in place. We're now at a point where that decision in 2004 is now actually resulting in electronic health records being produced. So, for example, oxygen, blood oxygen readings are now generally recorded electronically. Every single reading straight into a patient record somewhere. So we're starting to like see a lot more stuff being set up electronic first, rather than let's write it on a bit of paper and put it in and store it as a PDF in a file. So with every year goes past, I see it getting easier from the actual storage of information and the receiving of information. Where the like difficulty is going to be is this interlinking of records between this hospital and that hospital, permissions, and then as well privacy and who has access and who can do what with all of the data.
Yeah, 100%. You know, like how do patients opt in? How do they choose what to share, what gets shared, and ultimately who owns the data? You know, we've dealt with this a number of times. There really hasn't been a definitive challenge and answer to who owns all of the data in these healthcare settings and who can, like if a patient says, I mean, it's different in Europe with GDPR and things, but even there, like there's an obligation to keep records. Could you say, like, purge me from the database? I do not want to be in this database. Take me out. I think, yeah, it'll be an interesting era of sort of privacy reform and things like that.
Yeah, and yeah, we personally with the company, we're required to keep medical records. Don't quote me whether it's 7 or 10, but it's somewhere in that scheme of things. And clinical decision making. So if someone wants their data deleted from our system, we can only do so much.
Yeah, it's a sort of balancing act between sort of that, you know, they call it the right to be forgotten in the search space, but also like there is a medico-legal requirement to store this information for a certain period of time. And, you know, whenever I've gone to the doctor, you know, I probably consent to having my records saved, but I don't explicitly know who is storing that data. I need to trust my doctor that they're using a provider that I would be comfortable with. But nobody's saying like, hey, I use Google or I use Oracle as my backed medical record. Are you happy for them to store your data?
I was trying to think of this as well, where there was a similarity or an analogy that in another industry here. And the one that I could think about was tax, right? Your tax file.
Mm-hmm.
And that's all government owned and controlled. Like, you know, someone doesn't own my tax details. I submit that to the government. I give permission to people to look into it, and there's people that can write to it. You know, if you buy shares, you can and you put your tax file number in Australia, they'll automatically update in your tax and things like that. But ultimately, the government is the holder of that information. And so I wonder whether if there was any other analogies that I could think, any other analogies in this space.
Yeah, I mean, here in Australia, they had My Health Record, which was supposed to be that for health. So, I mean, it was a debacle. So many people opted out. It doesn't really store anything useful. But that was the government's attempt at doing that. I think where the tax scenario differs a little bit is that, you know, your shareholding, you know, whether it's chess or, you know, your crypto exchange or whatever, they can write information to your tax file, but they couldn't say what's Tom's taxable income this year.
Yeah, and they have no need to. They have no need to read from it. There's only two people that need.
Yeah, and then like they couldn't even.
There's only three people that need to read from your tax, which is your accountant, yourself, and the government. Yeah,
exactly. Which you know, in health, it's sort of a different scenario. There's a lot of potential readers. And, you know, if Google was the health record and you'd seen a couple of different doctors, Google would want to pull all that doctor's information and put it in the same place. But I agree. It's a tricky one about whether even when it was the government, there was so much backlash against My Health Record because they said, I don't want my data in some centrally stored government readable thing.
Yeah. I also learned that when people refer to unstructured data, they included images. I thought it was just referring to text. And we haven't even cracked the unstructured text problem yet, let alone unstructured images from a searchability point of view, which is going to be a fun few decades to crack that one.
Definitely. There is so much taken for granted in the fact that, you know, you have these human brains as computers as the interface between all this, and they say, I read the report, I looked at the image, I could make that link myself, but oftentimes images, you know, MRI scans are not annotated. It's just taken for granted that if you say, left base of the prostate in the transition zone, the person reading that report knows what that lingo means and can see it and make reference to it. But yeah, it's very, very unstructured.
So in summary, tech companies are spending a lot, but are they spending enough? I'm excited to see them starting to ramp things up. I think there's going to be people falling away from this. There's going to be less. We're going to be talking less about all of them: Amazon, Microsoft, Facebook, and Google investing in it, and we're going to be talking about one or two of them investing quite a fair bit in it in the next few years. And I suspect they're going to start ramping up as well as they start to get some wins and as their VC model starts to pay off, because I think it will. So I'm very excited for what these companies will do to the space. As you said, I'm very excited what they'll physically do as well with what they're producing, but also the infrastructure that they'll create for other companies to be built on top of. For example, like just wearables alone, there's an entire industry of tech companies that could be built on top of wearables, assuming they keep going the same way they're going with the FDA applications.
Yeah, 100%. All right, well, top 300 Google portfolio in health.
Number 1,
all right.
Google Health.
Yeah, good. All right, sweet. Any more you want to chat about in terms of Google?
Always with you, mate. But we should let the listeners get on with their day and get to the what is quickly becoming the popular topics of this podcast is AI.
Party. That was a joke because my topic for this week is this new Google research model, Parti, which is an acronym, and I did look it up this time. I wanted, every time Tom says, what does that stand for? And I say, fuck, I should have looked that up. It's Pathways Autoregressive Text-to-Image Model. So really it should be Partium, but I guess Parti sounds cooler. So what this is, it's a new text-to-image generator, similar to DALL-E 2, similar to Imagen. And, if you've been following along, Imagen from Google came out pretty recently. And this is another model in that family from the same group that produced Imagen. And it's a different flavor, where Imagen is a diffusion model similar to DALL-E 2, which really is about how they go from the text representation to the image. So there's diffusion, and in this case, autoregressive. I'll get into the details, but it's just about how once you've encoded the text, how you get the image out the other side, two different methodologies. And what's interesting about this model is they trained some huge variants of it, up to 20 billion parameters. And the results are pretty awesome. But this paper dove into a couple of topics I want to talk about, which I looked into, is how they assessed it, how that compares to some of the other models, where they specified some limitations. I think they did a really good job of talking about the limitations of this model. And also an interesting process that they did, which was evolving prompts over time. So to be dog on the beach with a hat, dog on the beach with a hat next to a cat, and looking at how the model sort of evolved its outputs over time, which I just think was very cool. So definitely check out this paper. It goes into a lot of detail. But maybe we'll dive straight in, starting with a little bit of summary of how the model works. So similar to...
I would like our readers to know, listeners to know that I've never seen Elliot more prepared for this podcast. So I'm very excited for this episode. He's written a couple of hundred words.
Yeah, which is not a lot given we talk for so long. But I thought, you know what, I'll read the paper, I'll do a deep dive. So the model is text to image. If you've been around this space, you've seen DALL-E, you've seen Imagen, and this is very similar. Like those models, it sort of works in 3 stages. it takes the text and codifies that text into a representation, a vector internally, so a whole bunch of numbers. It then uses those numbers to generate a low-resolution image. And then there's a third stage which takes that low-resolution image and turns that into a high-resolution image. So something that's called super sampling.
Is there
so
DALL-E,
yeah.
between those stages, is there like a kind of checkpoint or feedback where it's like, this is the correct low resolution, now let's make it high? Or is it, why do they split up? Why do they split it up between low and high?
The way part of it is a memory constraint. So you just can't, it's not easy to generate models big enough to do the full thing. They actually train these models initially separately. So they'll do a text encoding model, and then they'll decode that text back into the text representation sometimes, or into a picture with a known caption and try and train it that way. Then they'll take high resolution images, downsample them, and then try and get the original high resolution image for that final stage. So they're trained in separate parts, and then they're put together as one final model at the end. DALL-E 2 is similar. I think it's 3 or 4 different parts there that have come together to create these models. So we call them models, but really it's an amalgamation of a few different things that come together to do this process.
I just had this really cool thought about it, in how like 20 years there's just going to be companies that are like companies and institutions that are known for the text encoding model, and we're just going to be this like percentage point battle between them, and we're just going to have such great models because of it.
Yeah, 100%. Like, if we find a way to get interoperability between these setups, there is a lot of potential here for, retraining Parti, but with a new text encoder setup and getting an incremental gain from that new addition, which is very cool. And it's kind of what's happening already. The middle stage, which was the text to image, was a very well-known model that had been pre-trained on other data and was retrained here in context. I can't remember its name because it's like a weird acronym, but it's a transformer-based model that's been used in a lot of different circumstances and is now being applied here. So this model was pre-trained, or the text-to-image part was pre-trained on some big data sets, one called C4 and one which was an internal pairing of images and text. And then the super sampling one was similarly trained and then stuck together. And as I said, they trained a few different variants of this with sort of parameter counts from the 350 million mark up to the 20 billion mark, which is a huge range. And there's a good section in this paper, which I won't go into because it's extremely technical, but about how they managed to train a model of 20 billion parameters and how they did the parallelization across devices. And it's a pretty interesting piece of like sort of software architecture and engineering, just looking at that.
Can you give us a bit of scale for that 20 billion? So, if I'm doing my machine learning 101 in engineering, how big's my model in terms of parameters? And I know this might not be the way to compare things, but yeah, can you give us a bit of scale of how big these parameters are? This model is, sorry.
Yeah, absolutely. I mean, 20 billion is definitively out of reach for you or me. You have to be a Google or an OpenAI or an AWS to be able to do that. Let's say a neural network with a couple of layers, each parameter is one weight that gets trained. If that's let's say that's a floating point number stored in the computer, maybe that's, 32 bits or 4 bytes. And 20 billion of those, including their gradients, is going to be gigabytes upon gigabytes upon gigabytes of RAM and GPU RAM. And so, your average GPU, I got a fairly modern GPU. It's got, I think, 8 or 11 gig of RAM. I bought it because I had a lot of RAM. This will be hundreds upon hundreds. And that's per single instance. And they try and train these things in batches. so that it doesn't take the rest of time to train. So you're talking about hundreds of gigabytes of GPU memory. So
and they do the batches in parallel
of GPUs. Yeah.
So,
it's
if we tried to train
wild.
this model,
it's like data center level.
We would accidentally end up with a bill from Google Cloud for like $10 billion.
Yeah. And they would not even be able to provision you enough GPUs to train this in a reasonable amount of time.
Yep. Wow.
Even with a batch size of 1. Yeah. It's crazy. And it's awesome, but it also
is it
like
the big, like one of the biggest trained models ever, would you say? And can you say that?
It's up there. Like all of the big train models are in the sort of billions. GPT-3 was, I think, 10 or so, 10 to 15 billion. DALI was 3.5 billion, which is interesting that it's so much less. It was a sort of big win in that regard. So I don't know if anyone's done a trillion parameters yet, but, the tens of billions is certainly where all of the cutting edge stuff is.
Wow.
And what it's kind of revealing.
I want to see the graph of like models over time since computing's been around to percentage of computing power. Like I want to see that graph.
Yeah, man, 100%. And now that crypto is kind of dead, there's a whole bunch of GPUs for cheap on the market because nobody wants to mine Bitcoin anymore. So who knows? We might see the trillion parameter market soon. But yeah, I mean, it's cool. It's a great piece of sort of engineering from that side of things, beyond just the innovation in the AI. But let's talk a minute for how it was evaluated. So how do we know these models are good? Because at a certain point, they all kind of look good, but we've got to be able to pin them off against one another. So this model was assessed both by humans looking at the outputs and by some quantitative metrics. So the human one first is pretty simple. It's show the person either 2 images and say which one looks more real, or show them image and text and say which one of these images better captures what's in this text, and they vote, and you get enough people to vote on it, and you compare how people see the images, back to that Turing test. Does it pass the muster? But that's subjective. Naturally, it's subjective. It's people. The metric that seems to be popular at the moment for comparing these, which luckily DALI 2 used as well, so we can do a bit of a head-to-head, is the Frechet inception distance, or FID. And what it does is it takes a real image and a fake image, and it runs it through a model called Inception, which is a big classifier model. And it takes the neural network activations at the second last layer, which is, typically where you would go if you're like fine-tuning a model. That's sort of the internal representation that isn't the probabilities per class of the real and the fake image. And then it calculates this metric called the Frechet distance. And it's a measure of similarity between originally 2 curves. In this case, they treat the output as a multivariate Gaussian. The intuitive model of how this works, which I love, I took off Wikipedia. So if you imagine a person walking their dog on a leash, and you have a line that sort of follows the person and follows the dog as they go for that walk, they're going to be somewhat correlated because it's a person walking their dog. But the dog, as I know, and as you know, Tom, people with dogs, the dog doesn't just walk next to you the whole time. It goes all over the shop. And the Frechet distance can be thought of, okay, if we assume that this is a person walking their dog and we know their position over time, what is the shortest possible leash that this dog could be on that explains how the dog and the person are moving together?
Oof.
Which I think is really cool. And the closer those two things are, obviously the more aligned those two are. So if you pick up your dog, you and the dog are going to move in space together. If you have a 20-meter leash, there can be a lot of variability around that. And hilariously,
great analogy.
I thought that captured it so well. There's a little text snippet at the end of the Wikipedia explanation which says, technically speaking, this is a symmetric measure, so this would also be true if the dog was walking the human, which I think is just such a great thing to add to a Wikipedia page.
Have you seen that oatmeal comic? The Oatmeal's a famous comic, and he does this entire series on dogs taking humans for walks, and written from a human perspective of I must take my human for a walk today. Show notes.
I'd believe it, man. I would believe it. As somebody who gets pretty much pulled around the block by my dog, he is definitely walking me. So that's how it got compared. On those metrics, if you look at this, say, compared to DALL-E 2, keeping in mind that it's 20 billion versus 3.5 billion parameters, this performs better. It's better on the FID, it's better on the human scores. Even the 3 billion variant of this model seems to outperform DALL-E 2. So it's interesting in that regard. They were sort of worked on roughly at the same time, so there's not as definitive a head-to-head. And frustratingly, neither model is available. So, nobody can do an independent comparison of the two. Maybe that'll change over time. We'll see.
Wow.
Yeah. So the second thing that I thought was cool, which is definitely worth talking about here, is they did a really good summary of some of the limitations of these models. So we've talked about it before with the Viscutis and the magic vegetables.
The secret language of DALL-E 2, right?
The secret language of DALL-E 2, yeah. And this paper looked at a lot of different failure modes. It gave examples of those failure modes and tried to explain them. So I want to touch on a few of those here. One of them was text. If you take a look in the paper, and I'll try and put an image up here, the more parameters the model had, the better it was at responding to text prompts. So the one they have is like a sign that says deep learning. At the sort of 3 billion mark versus the 20 billion mark, this first sign is unreadable. Like it sort of says deep learning, but it doesn't. It fucks it up. Whereas the 20 billion gets it spot on, which goes to our point of, is there a secret language of DALL-E 2? And the answer might just be DALL-E 2 is too small to be able to memorize all the words, so it just sort of mashes them together. And it's like, babies talking. They just sort of mash words together and make sounds and try and do the best that they can. So who knows? A 20 billion DALL-E 2 might not have Viscutis. It might have vegetables. Another one that we see a lot is what they called color bleeding. So in that case, it's if you said, I would like, 2 jackets next to each other, one of which is blue. The model, more often than not, makes other stuff blue as well. So maybe that other jacket, it might make the table blue. And it's a thing that they call color bleeding. They have a similar failure mode, which they call feature bleeding, which is if you say, I want a checkered jacket next to a pair of pants, the pants are likely to be checkered as well, because it takes that context and applies it to as many things as it can. One other spot it fails is counting. So if you say, I want 3 ducks and 2 apples, the model tends to mess up the numbers. It's not very good at really understanding how to instance an object multiple times. So another thing that this model, or the authors here have pointed out as a potential issue, is spatial relationships. So if you say a dog to the left of a cat, the model is not the best at putting the dog to the left of the cat. Similarly, negation. So there's an example in there which is bananas on a plate next to a cup that a cup not full of orange juice, and the model very often puts orange juice in that cup. One other one, which I found really interesting, is that the model seems to get things wrong when there's common misconceptions. And this is a reflection on the training data for sure. So one example that they gave in the paper was images of the Great Pyramid. So a common misconception is that the Great Pyramid is, when looking north, I believe, the middle pyramid, in the collection of what we typically see as pyramids. That's actually not the Great Pyramid. It's a pyramid called Khufu's Pyramid, and the reason that this happens is that it's likely that within the training set there is a lot of references to the Great Pyramid that mislabel this data. And this sort of ties back into one of the ideas that they had around why this model hasn't been made available, is that they suspect pretty strong data bias and pretty strong bias in the model itself. And they're worried that until they can work out how to best control those limitations, this model has potential for more harm than good, so they're not releasing it to the public, which is a reasonable thing to do, assuming they do actually go and work on this and then eventually release it. There is every chance that they just won't, and they'll publish this paper and then move on with their lives. So we'll see. And we are back after some light technical difficulties when London lost its internet.
You sang your elevator music the whole time, right?
Yes. It's actually now Thursday of the following week. I've been singing this elevator music for a long time, and I haven't slept.
And we're also not sure whether we have any of my upload from the previous week.
Yeah, so it may well just be me talking for a long period of time, but we'll see.
So I had the question that I wanted to kick in here as well is, and I think you were starting to answer that, but if we think about the three parts of this model, like the tokenization, the low resolution image, and the high resolution image, where does this run into bottlenecks? And what are those bottlenecks? Because I imagine there's I'll say an intelligence and accuracy bottleneck, but then there's also a compute power bottleneck.
Yeah, definitely. I think the fact that we have a super resolution component at all is sort of telling that there is a big bottleneck in the token to image generation. Like, we cannot take text tokens and generate 1024 by 1024 images right now. You just need too much RAM. That could come down to model architecture because, with super resolution, for example, you can do that in a patch-wise sort of scenario. So you can do a super resolution. You could break the image, let's say, into like 16 boxes and do a super resolution on each and then combine them. So there may be innovation in the model that you could do there. But the other thing to keep in mind is that like a lot of these training bottlenecks and the sort of RAM bottlenecks exist mainly during training because you need to compute gradients all the way back through the model, and that's where it gets really expensive. The actual inference time tends to be a lot simpler. You can do things like quantization, so you can take those float weights and convert them to integers, which are much smaller, and do sort of mixed precision and things. So yeah, it's a training barrier rather than a inference barrier.
Very cool. So we kind of talked into how this compares to DALL-E 2, but pound for pound, parameter to parameter, how does the 20 billion model compare to the 3.5 billion for DALL-E 2?
Yeah, I mean, the 20 billion parameter model, according to FID and the human related scores, it's just like way better. But if you look at the 3 billion Parti model, it's also better on the FID scores. The difference is sort of 8 versus 7.5, I think. And FID, it's not something you can really get a gut feel for what that means. But for example, the 20 billion model is 10, so the difference there is much smaller. And the 3 billion model, which goes to show, there's a post by Gwern about the scaling hypothesis, which goes into this, which is, I think it's him, is the path to AGI and really advanced models just more compute? And I mean, personally, I think it's a mix of more compute and innovations in model architecture. I mean, transformers really have opened up the pathway to a lot of these models, whereas, traditional sort of convolutional neural nets, even light attention, really wasn't achieving these results in the past.
Yeah. This is what we discussed today on like how much compute this 20 billion parameter model is has really put into context to me like how much power would be required for AGI. If this is like a very specific scenario to be able to hit AGI, it's crazy to think about what would be required from an infrastructure point of view to support that.
Yeah, and like frankly, by today's standards, it's not feasible. If the answer is just more compute, we're not going to be able to get enough compute because, I mean, you think about the human brain. Like, the human brain doesn't, like, it's not like we need to eat 6 pounds of uranium a day to power our brains.
Yeah.
Like, the power consumption, you know, the watt per capability of the human brain is still much, much better than these models.
And none of this is linear, right? Like, 3.5 is not 6 times less than a factor of 6 less than 20 billion, right? In terms of power consumption, in terms of time to train and time to operate, right?
Yeah, not perfectly. I mean, yeah, it's proportional. The runtime performance, the sort of inference performance is probably not meaningfully different. The training time depends how you split up the training, like how you parallelize it. But yeah, in terms of time, it's not a huge amount of difference if you can get more GPUs, but in terms of power, it obviously goes up with these extra GPUs. And yeah, I think this is why Google and Amazon and all these other big players are investing in custom silicon because, you know, GPUs are by their very nature quite general because, you know, you got to do everything from play Cyberpunk to train an AI model. Whereas if you build like a TPU, which is the Google one, and AWS has one, but I've forgotten the trade name for it, that's really just about AI-specific operations, you can get a much better trade-off of, you know, compute power to watts.
Amazing. So interested to see what...
I mean, it's a cool time.
So interested to see what the manufacturing space for hardware looks like in 10 years' time.
Yeah, definitely. I mean, and, you know, we're seeing it with Apple as well, with the M1 chips and the M1 Max. Like, people are building their own silicon. It'll be interesting to see if there's a revival of sort of domestic silicon production in places like the US, where a lot of these companies are headquartered.
And no longer just that one Taiwan Semiconductor. The, like...
Yeah. Where, like, a bad, you know, power outage means that the whole world's without chips, which we kind of saw over the last 2 years.
So you were kind enough to send me the paper, and really I just looked at the pretty pictures rather than read anything. But I did. I saw that there was a secret language popping up in the paper from Parti. Could we have DALL-E 2 and Parti have a conversation in their secret languages, and would they understand each other?
Yeah, I mean,
does Viscutis mean Viscutis?
Yeah, my guess is probably not. I don't think Viscutis translates across entities. But yeah, I mean, I think what was really interesting is that as these models got bigger, the sort of weird cryptic language stuff went away in the generated images. You know, the 3 billion model, there's an image of a kangaroo holding a sign that's, I think, supposed to say "Welcome, friends," and it looks kind of close but slightly nonsensical at 3 billion, but at 20 billion it's spot on, similar with the sign that says deep learning. So that further justifies the fact that, you know, DALL-E 2 doesn't have a secret language. It's just got weird internal representations where it's got to mash things together in order to be able to generate such a wide variety of images. And somewhere in the realm of 3.5 billion to 20 billion is the sweet spot for, you know, the letter A is the letter
Fluency.
A. Fluency,
That's
yeah,
so...
at least in English. I mean, God help it if it needed a language with more than 26 characters.
Yeah. Actually, it's like side note, but like, how do these models go if you compare alphabet language versus character language? So, for example, like how would these models go with Chinese versus English? Do they change or?
I haven't seen I haven't seen anyone dig into that, but it's a really good question. And yeah, I think this comes back to this issue of data bias, is that most of this training set is English language and content that sort of matches that. So my guess is it would do quite poorly, which says that we probably need to work on how to get varied data sets that are sort of globally relevant. Because, otherwise you're going to see problems like that.
It's so interesting because, not that I speak Chinese or Japanese or a pictorial based language. Is that the right way to say it? Anyway, a character-based language. But my understanding is that it varies in both like being extremely literal and also extremely evocative as a language, because some things just literally mean exactly what they mean, but then slight changes will change the entire meaning of something and provide a lot more. And it's essentially a picture, and at the end of the day, a picture is worth 1,000 words. So you're able to communicate a lot more within it. So I wonder whether, I just feel like it would both be better and harder for AI to interpret at the same time.
Yeah, 100%. My guess is it'll be bad. But not that couldn't be resolved.
Yeah. So my next question on this as well is, so we've figured out that they will be able to talk. DALL-E just needs a bit more training and a bit more development time before they'll be able to speak to one another. But what this made me think of, and the reason why I thought about it, is as I was reading this paper, I can't really visualize how this stuff works, like what tokenization looks like, and I actually asked you this question, like, how does it generate the images? Could I just ask Parti, how do you think? And it'd be able to draw that for me. Or create that for me.
Yeah, I mean, you could try. People did this with DALL-E, and people asked Lambda about this. People have asked the AI Sophie about this, which is one out of Wolfram, which one of our watchers commented on in one of our previous videos. And by and large, these models don't know how they work internally. So it would give you something, because this model, no matter what you say to it, it will always generate an image. Whether that's a deep, that subreddit, I'm 13 and this is deep.
Yeah,
have you seen that one? It's like memes that, seem deep to a 13-year-old. I think it might be that level of deep.
I suppose, that was a cheeky way of asking, could we use this to help us visualize things that we struggle to visualize in terms of experiments? So, for example, show us, like, let's just pretend we're back in the 1900s and show us what an electron looks like when Niels Bohr visualized it for the first time, or show us what DNA looks like when Watson and Crick visualized it for the first time.
My gut says no, because the only reason I say that is that, like, these models kind of get all of their understanding about the world from the images we feed into them. So you could probably put in something like, show me a double-decker car, because there's enough cars, and like it kind of can understand basic concepts about how to vary a car to have two levels. It probably wouldn't be very practical, but something like that, or something we've never seen before, like show me the inside of a black hole.
Yep.
There's just not really any meaningful way for it to have a conceptual understanding.
That one's easy.
Yeah, you don't know.
I'm trying to you right now.
You don't know.
Okay, and the final question that I had, which is obviously the one that every layman asks someone who knows what they're talking about. Applications. Where are we going with this?
Yeah, which is a great question.
It's an easy question. It's a lazy question.
That's not a lazy question. It's reasonable. I mean, you can make stock photos and you can do art and all of that sort of stuff, and that's great. Right now, I'm not seeing a whole lot beyond that. But I did have this idea, which someone should totally make, which is like an Instagram backed by these generative models, where the only thing you're allowed, anything you post as text gets fed into one of these models and an image is generated. And if let's say you post something and you think it's cool and I retweet it, I have a chance to edit that prompt, generate some new images, and we can, track the lineage of this stuff and see what's cool. I think that'll be a great art project. There may be some applications in, say, let's say you're trying to build a house and you say, show me a 2-story house in a mid-century design with a garage and a white picket fence. You may be able to get like a little bit of that, and then it's like, okay, show me the same house, but with a, modern feel and a pool. And you might be able to get something useful out of that. Again, though, I think we're a little ways away from that, to be honest. But, what I will say is that, GPT-3, originally a text-based engine that took prompts and generated text, has become things like GitHub's Copilot program, which now looks through code repositories and can help you generate code as you're writing code. So, who knows? There may be interesting applications here that are a domain-specific example of putting this together. Like, you could make, I don't know, maybe you could make children's books. It's like, hey, I've got a nice little story for a children's book. I don't know an illustrator, though, so I'll do that and try and generate a story. I don't know.
Yeah, I can see definite applications as for people that want to create very rich content very quickly and very easily.
Yeah, 100%. I think we're going to have a lot of fun with these models. That is for sure.
Yeah.
Yeah.
So what have we touched? We've hit Lambda, we've hit Party, we've hit DALL-E 2.
Yep. We haven't done GPT-3, but we've talked about it in passing. The other topic I was going to talk about today, but we can talk about another week, is Copilot, which just went public this week. There's a lot going on in this space. I'd like to do a similar dig into some of the more medical applications. Some of the protein folding ones and things like that. I think are fascinating. But this came out this week, so it seemed too good not to do. It's a hot time for AI applications.
Got weeks of content ahead of us at this rate.
Exactly.
Well, mate, it's always a pleasure to learn from you in this. Get to sit back and watch you talk about all this. But what else you been doing at the moment? Anything to plug?
Oh, what else have I been doing?
We're a bit too podcast focused at the moment. It's great. We recorded our first book club this week, didn't we?
We did. That one's not out yet, unfortunately. I was meant to edit it today, but I had to download 500,000, and that's not an exaggeration, DICOM images for an AI project that we're doing, and that took up most of my day. What do I want to plug? I don't know, not much. I really haven't been doing much.
Let's just plug the podcast. We're loving it.
Yeah. I mean, we haven't said it, and maybe I'll do a similar clip at the beginning, or I'll put a little graphic in or whatever. But if you are enjoying this, hit like, hit subscribe. As another YouTuber I heard said, it's free, and it helps us know that you like our content. And if there's stuff you want us to talk about, throw it in the comments. We do listen. We try and, make sure that we're keeping up to date with what people want to hear. So, hit us up. Let us know what's going on. And
I'll share the screenshot.
What about you?
I'll share the screenshot of how excited Elliot was when we got a really deep and thoughtful comment on our YouTube, on one of our videos. He was so excited. Excited.
We did. I woke up to it. It was very cool. Leave a comment. Gives me that dopamine hit. And also, there's a lot of good people out there working in this space, so we'd love to connect with you. So, What about you, Tom? What do you want to plug?
Just the podcast. The way that we divvy up the work is Elliot does the main ones and I do the shorts. So, got any feedback on those shorts? Let us know. We're I've been they're getting better and better with every single one of them as I figure out how to do video editing. But having fun making them. So we'll get a few good ones out of this one as well, I reckon.
Indeed. And if you're watching this and you are an editor, at some point we are going to want to not edit these videos ourselves. So hit us up.
Yep. Oh shit, we got to get these on Spotify. We said we would.
Yep, we did say we would. We'll do
If
that
you work for
eventually.
Riverside, can you please tell us whether you can do it on Riverside? It's not exactly clear.
Good stuff. All right, friends, take it easy. This will probably be up early next week, so I hope you had a good weekend. I hope you're doing all the good stuff. Stick around, and we'll talk
Bye,
soon.
everyone.